Okay, so the next piece, the directions say determine if the binomial is a factor of the following. Okay, so what that means is, so here's like our first problem. So you'll be given a problem, 50k squared plus 50k cubed, excuse me, plus 10k squared minus 35k minus 7, and then the binomial is 5k minus 4. So to determine if this binomial of 5k minus 4 is a factor of this polynomial, what I actually need to do is I need to divide it and I need to see what the remainder is. Okay? So let's go ahead and divide it. Let's get more practice with that. So I have my 5k minus 4, and my dividend is 50k cubed plus 10k squared minus 35k minus 7. And so I have to ask myself, 5k times what gives me 50k squared? That answer is 10k squared. So 10k squared times 5k is 50k cubed, and 10k squared times negative 4 gets me negative 40k squared. So I now need to subtract this. Oops, wrong thing. So I need to distribute this negative, so that becomes a positive, and I'm distributing that because it becomes an addition problem when I distribute the negative. And now I have 50k cubed plus negative 50k cubed. That eliminates. And I have 10k squared plus positive 40k squared, and that gets me 50k squared. Now, when I bring down, I actually am going to bring down the whole rest of it. We didn't see that in the other problems because they were smaller polynomials, but I like to bring down everything because a lot of times people forget about this constant. Okay, so I'm bringing down everything that I have not divided yet. And now I have to ask myself, what times 5k gets me 50k squared? That would end up being, what, a 10k, right? Oh, that looks kind of gross. Let me rewrite that. A 10k. There we go. 10k times 5k gets me 50k squared. And 10k times negative 4 gets me negative 40k. And now I need to subtract these. So that means I need to distribute this negative. There we go. So now I have 50k squared plus negative 50k squared, and that gets you 0. Then I have negative 35k plus positive 40k, and that gets me 5k, and I bring down that minus 7. And so then I have to ask myself, what times 5k gives me 5k? Well, that's 1, a positive 1. So 1 times 5k is 5k. 1 times negative 4 is negative 4, and I need to subtract this whole binomial, so you know what that means. I need to distribute that negative, so that way our signs are all good. So now I have 5k plus negative 5k. That eliminates, that's 0. And I have negative 7 plus positive 4, and that gets me negative 3. So that's a remainder of negative 3. So my answer is 10k squared plus 10k plus 1 with a remainder of negative 3. That's the answer to the division problem. Now remember that the original problem said determine if the binomial is a factor. If it's a factor, it will have a remainder of 0. If it's not a factor, it will have a remainder of something other than 0. So 5k minus 4 is not a factor, okay, because we had a remainder of something other than 0. So let's make a note of that. If you have a remainder of 0, the binomial is a factor. if you have a remainder of a number other than 0, the binomial is not a factor. Okay, so that's very important to know. And that's going to actually come up in the next lesson about understanding what the remainder is, if it's a factor, if it's not. Let's try another problem like that to determine if it is a factor. So I have 4x cubed plus 21x squared plus 35x plus 24. And the binomial that we're looking at is x plus 3. So we want to find out if x plus 3 is a factor of 4x cubed plus 21x squared plus 35x plus 24. So let's go ahead with our division. Let's get it all set up here. So now I ask myself, what times x gets me 4x squared? Well, that would be 4x. So 4x times x is 4x squared. 4x times 3 is a positive 12x. Oops, you know what I just realized? I totally messed that up. This should be a 4x cubed. So that means what times x gives me 4x cubed? That would be 4x squared. Okay, so 4x squared times x is 4x cubed. And 4x squared times 3 is 12x squared. So now I'm going to subtract this. And I'm going to distribute the negative. So with that, 4x cubed plus negative 4x cubed eliminates. And then I have 21x squared plus negative 12x squared, which gives me 9x squared. And remember, I'm going to bring everything down that I haven't divided yet. Now I have to ask myself, what times x gets me 9x squared? The answer to that is 9x. So 9x times x is 9x squared. 9x times 3 is 27x. So now I need to subtract this binomial, which means that I am going to distribute the negative. So that way it now becomes an addition problem. 9x squared plus negative 9x squared eliminates, and it's 0. 35x plus negative 27x is 8x. And then I have to bring down my 24. And now I ask myself, x times what gives me 8x? That would be 8. So 8 times x is 8x. 8 times 3 is 24. And I need to subtract this, which means I need to distribute this negative. So now I'm going to combine my like terms. 8x plus negative 8x is 0. That eliminates. 24 plus negative 24 also eliminates. So I have a remainder of 0. Now normally you don't have to write remainder of 0. I'm just writing that here to prove that x plus 3 is a factor of this polynomial because I got a remainder of 0. So we can say x plus 3 is a factor. Okay? And that answers the question because it asked if the binomial was a factor. So it's a little bit, one extra step after the dividing. So now you have all of the notes that you need to be able to divide polynomials with long division.